Hello class, welcome to lesson 2.9, which is about weighted averages. By the end of this lesson, you should be able to solve mixture problems and you should be able to solve uniform motion problems. Okay, so a big part of weighted averages or any type of problems like that is they all tend to be word problems and you have to piece together multiple equations, okay? So I'm going to walk you through this process. So let's read our first example. We have a tea company sells blended tea for $25 per pound. To make blackberry tea, dried blackberries that cost $10.50 per pound are blended with black tea that costs $35 per pound. How many pounds of black tea should be added to 5 pounds of dried blackberries to make blackberry tea? Now, if you're anything like me, you read that, and by the time you reach the end of the problem, you forgot what the first couple sentences said. So let's go through, let's underline and make, like a visual to help us analyze this information. Okay, so we're making tea, I know that much, all right, and we're told some ingredients. We're told about dried blackberries, and we're told some information about them. So I'm going to write blackberries. Okay, and I'm just going to, I'm going to make the table, mine's a different color. Alright, so I'm going to say this is my ingredient list. Okay, and we have information about the blackberries. We know that the cost per pound, the cost of the dried blackberries per pound is $10.50, right? So we have $10.50. And what else do we know? We also know that the black tea, because the dried blackberries are blended with black tea, so that's another ingredient. So we have black tea. Costs $35 per pound. And we want to know how many pounds of black tea should be added to 5 pounds of dried blackberries to make blackberry tea. So we have another type of tea here. We have blackberry tea. So I need to add that to my list as well. Blackberry tea. Okay? And fairly often, unless you're doing a distance problem, in this first column where you're listing things like that, you're going to have 3 different items, okay? And what other information do we know about the blackberry tea? If we look up at our first sentence, a tea company sells blended tea for $25 per pound. So we know that the cost of this blackberry tea, because it's a blend between the dried blackberries and the black tea, and it is $25 per pound. Okay, that's where I found that. And now, what we want to know is how many pounds of black tea should be added to 5 pounds of blackberries to make blackberry tea. So I need to figure out the number of pounds needed, right? We're told 5 pounds of dried blackberries, so that means for dried blackberries, I'm going to put 5. And we want to know how many pounds of black tea. So we don't know what that is yet. So since we're dealing with a weight, I'm going to say W, because I don't know how many pounds that is. And then to make the blackberry tea, the weight of the blackberry tea combines the weight of the blackberries and the black tea. So all we have to do is take the 2 rows above it, so the 5 and the W, and add them together. That'll be the weight of our blackberry tea. Our last bit of information, we're concerned with what it costs, right? we want to know how much money we need to buy the tea that we want. So in order to figure out our total price, we know our cost per pound and we know the number of pounds. So what we can do, we can take 1050 in this instance and multiply it by 5 in order to get our total price. The reason I set up a table is because now all I have to do is take the two blue columns and multiply them together in order to get my last column. Okay, so now I have a 25 times 5 plus W. Okay. Now you may be wondering how this helps you, but once you have this table set up, life gets quite a bit easier. I'm not going to say easy, because easy is a relative term. But all that you have to do is you take the first two rows, these first two rows, you add them together, and they equal your last row. So it sets up the equation you need in order to solve for your variable. So you'd say 52.50, because we have 1050 times 5, and 1050 times 5 is 5250, plus 35W equals, and then if we distribute that 25 times 5 is 125, plus 25W. Now this looks exactly like what we've been doing all chapter. I can tee it up. I'm going to subtract 25W from both sides so my W's are left on the left side. I now have 5250 plus 10W equals 125. And if I keep going and subtract 5250 from both sides, I'm left with my variable being alone on one side, and 125 minus 5250 is 7250. And to get W all the way by itself, I just have to divide both sides by 10. I'm going a little faster through this because we've been doing a lot of this lately, and I'm more concerned with the setting up the table and setting up the problems, okay? Alright, so I'm left with W equals 7.25. Am I done? Almost. I'm so close. Scarily close. Okay, maybe not scary. But I said W equals 7.25. What does W represent? So I go back to my table. I find W. W represents the number of pounds of black tea. Remember, our question was how many pounds of black tea should be added to 5 pounds of dried blackberries to make blackberry tea? The answer is 7.25 pounds of black tea. All right? And that is my final answer there. All right? I know that's a lot of information to take in at once, but go through, set up your table, set up your equation, and give it a shot, okay? It's okay if you don't get it right away. Go ahead and try this one on your own and see how you do. Hopefully you ended up with 5 ounces. If not, be sure to ask for help. Let's try another problem together. We have a car's radiator should contain a solution of 50% antifreeze. Bree has 2 gallons of 35% antifreeze. How many gallons of 100% antifreeze should she add to her solution to produce a solution of 50% antifreeze? Okay, so again, we are going to set up a table just like I did before, and this time I'm going to have my types of antifreeze. Oops, if I could spell. Types of antifreeze. Okay. And the types that I have, I know that Bree has a 35% solution. She has a 100% solution. and she has a 50% or she wants a 50% solution. So let's keep filling this out. All right, we know how many gallons Bree has, right? So one of my columns is going to be gallons. I'm really struggling with spelling today. Good thing I teach math, huh? Except I need to be able to write in all subjects. It's important. But gallons, and then this one's going to be a little bit different because there's a little bit less information. So the very last column I'm going to have is the amount of antifreeze. Okay? So this will make sense in just a minute maybe. How many gallons of 35% solution does Bree have? She has 2 gallons. How many gallons of the 100% does she have? We don't know. That's the question. That is what we're trying to solve for. So let's put a G right there. And what about the 50% solution? How many gallons of that? That's what she ultimately wants, right? She's going to combine the gallons of 100% to get the solution of 50% antifreeze. So we're going to have the 2 gallons of the 35% plus however many gallons of the 100% solution. So we put 2 plus G. Now the amount of antifreeze, what we can do, whenever you have a percentage over here, it saves you a step because in order to determine the amount of antifreeze, you take 2 gallons and then you multiply by the decimal version of the percent. So 35% is 0.35, and then our 100% is our gallons times 1.0, right? 100% is 1.00. And then our last one, we have 2 plus G, and then that's being multiplied by 50% or 0.5. Just like we did before, our top 2 rows added together equal the bottom one. So 2 times 0.35 gives us 0.7 plus 1 times G is just 1G, which we also write as G, equals, and then 0.5 times 2 gives me 1, and 0.5 times G gives me 0.5 G. I have to get my G's on the same side, so I'm going to subtract 0.5 G from both sides. I'm left with 0.7 plus 0.5, because 1 minus 0.5 is 0.5 equals 1. If I keep going, I can subtract 0.7 from both sides. Again, I'm going rather quickly through this part of it. If you still have questions on the solving for variables, be sure to ask, okay? We now have 0.5G equals 0.3. To get the G by itself, we need to divide by 0.5. Oops. And we end up with G equals 0.6. What does G represent? Let's go back. G represents the number of gallons of the 100% solution. So we need 0.6 gallons of 100% antifreeze. Sorry, we're dealing with antifreeze. And that is my answer. Go ahead and try this one on your own, see how you do. Hopefully you ended up with 7/10 of a pound. If not, be sure to ask for some help or go back and watch the last example. It's very similar. All right, example 3. Example 3. Sarah took a nonstop flight to visit her grandparents. The 750-mile trip took 3 hours and 45 minutes. Because of bad weather, the return trip took 4 hours and 45 minutes. what was her average speed for the round trip? Okay, so something to remember, very important formula, rate equals distance divided by time. If we want to figure out the average speed, we need to know the rate of the plane. We need to know how fast it's going, right? So on the way there, we did 750 miles in 3 point, how many? 45 minutes of 60. In order to figure out the decimal, you do 45 divided by 60, and eventually that works out to 3/4. 15 goes into 45 3, 15 goes into 60 4 times. So 3/4 is the same as 7/5 hours. And if we divide 750 by 3.75, we get 200 miles per hour. And then on the return flight, we have 750 divided by 4 hours and 45 minutes, so that's going to be 4.75. And that is 157.9 miles per hour. Now, in order to do a weighted average of these two, the way that you do these, because those first two steps, hopefully fairly straightforward, but weighted average, you do the rate of going and then the time of going plus, I wrote too large. Let's shrink this down a little bit if it'll let me. Oh, everything is too big, so we will go like this. Okay. The rate of going times the time of going, and then you have the rate of return times the time of return and that's all over the time of going plus the time of return. Okay, so let's plug some numbers in for that to help make sense of what I just said. The rate of going, on the way there we went 200 miles per hour times 3.75 hours, and then we're going to add that to the rate of going 157.9 miles per hour times 4.75, and then we are going to divide it by the sum of the amount of time, the total time. So 3.75 plus 4.75. And this ends up working out to approximately 176.47, or you could just say about 176 miles per hour. I recommend somewhere in your notes making note of this right here to help you, okay? Go ahead and try this next one on your own, see how you do. Alright, hopefully for this first one you ended up with 24 miles per hour. If not, be sure to ask for some help. I'd be more than happy to help you. We have one last example to look at in this video. I know this section's sometimes a bit more challenging, but you guys are capable of doing it, otherwise I wouldn't be teaching it to you, okay? So I believe in you. Let's finish song. Example 4, 2 cyclists begin traveling in opposite directions on a circular bike trail that is 5 miles long. So we have a circle bike trail, and it's 5 miles long, okay? One cyclist travels 12 miles per hour and the other travels 18 miles per hour. How long will it be before they meet? Okay, the way that we solve this, let's list. We have cyclist 1, we have cyclist 2, we know our equation for, we want to know how long will it be before they meet. So we're talking about some time. We have a rate and we have a distance, right? So in this instance, we're going to say distance equals rate times time. It's the same equation that we did in the last problem, except it's written out for a different variable. Okay, so if we have our rate, we want to know what is our rate. Our first cyclist is going 12 miles per hour. Our second cyclist is going 18. We want to know our time, and that is when they will meet. Okay, so how long will it be before they meet? This is where this one gets a little trickier. We want to know where they meet. That means, or how long it will be before they meet. So that means that the time has to be equal, right? Because they can't meet each other unless it's been the same amount of time. So we represent time in this instance with the t. And then we know distance equals rate times time. So we have 12t, and then we have 18t. You might be asking me, where does that 5-mile loop come into play? That comes into play when we're dealing with the equation. So we have 12t plus 18t, right? These are our top two, equals 5. Okay? Because we know our distance. This is our rate and our time. We know our distance. We were told our distance is 5 miles around that loop. So we set up our equation. 12t plus 18t equals 5. 12t plus 18t gives me 30t equals 5. So t it up. Divide both sides by 30. Divide both sides by 30. We're left with t equals 5/30ths, or 5 goes into itself once and into 36 times. So 1/6 of our label's miles per hour, so 1/6 of an hour, which, what is 1/6 of an hour? 10 minutes. So in 10 minutes, they should meet on the bike path. One last problem for you to look at. Good luck. Hopefully you ended up with 14 minutes. If not, be sure to ask for help. If you have questions on anything from today, be sure to ask for help. Like I said at the beginning of this lesson, there's a lot of steps. This can be a little bit more challenging than what we've been working on. But again, I believe in you guys. That's why I'm teaching it to you, okay? So good luck. Be sure to ask for help. I hope you guys have a great night.